going over problems 3, 4, 6, and 7. Number 3 says, if the ball in the previous question starts from rest at point A, calculate its speed at point B. And if you look here, A has 0 EK and has full EG. And then at E it has full EK and 0 EG. So then you do EG equals EK, and EG equals mgh, and EK equals 1/2 mv squared. So you solve it, you cross out the m's because the mass is the same and it doesn't change, and then you multiply both sides by 2. So then you're left with 2gh equals v squared, and you get the way you get rid of the square is by square rooting both sides. So then you're left with v equals square root 2gh, and that will be your answer for number 3. Okay. Number 4, this graph is given in the packet. So then what I did, I just labeled A as EG, B EK. This is when you're about to let go of the balloon, and this is when the balloon is about to launch. So H1 is equal to 1/2 GT squared, and D is equal to VOT. So then you solve those. So D equals V naught T, and H1 is equal to 1/2 GT squared. So then you divide by T, so you get V naught equals D over T. And this one you multiply 2 to both sides, and you get 2H equals GT squared. Excuse me. And then from here you divide the G, so you get 2H over G equals T squared. So now you know what your T is. Oh, and then to get rid of the 2, you have to square root. So then T equals square root 2H1, over G. So then you can plug that into T. So you have V naught equals D over square root TH1 over G. And then you start with your EG equals EK. And this EG is going to be 2 because we're solving for H2 now. So that's mgh2 equals 1/2 mv squared. You get rid of your m's. You multiply 2 to both sides, so you get 2gh2 equals v squared. And since you're solving for H2, you're getting rid of the 2g. So you're left with H2 equals v squared over 2g. And now you plug in your v. So you get H2 equals D over, H2 equals, D over 2H1 over G over 2G. 2. So then you will get H2 equals D squared over 2H1 over G over 2G. And then from here, you get H2 equals D squared over 2H1 over g times 2g. Wait. No, this is a g. So then the g's cancel out. So you do 2 times 2, which is 4. So then you get h2 equals d squared over 4h1. And that is your answer for number 4. I have no room for 6. So then I'll just erase this. Number 6. Oh, and then there's number 5. I got that one right, but I can repeat it for you. It says, at the same moment, a high-speed bullet leaves a horizontal rifle barrel. Another bullet is dropped from the same height. Which bullet hits the ground first? They both hit at the same time because gravity is pulling at the same rate. Alrighty. So number 6 says, starting with a vector diagram for the balloon launch. What's that? Try. Something, a relationship for the launch velocity in terms of the distance the balloon will travel. So, you do your triangle and you label it. This 1/2 gt squared. This is d. Ready? This is okay. So then d is equal to 1/2 gt squared, and you solve for the t, so you are going to multiply both sides by 2, so you get 2d equals gt squared, and then you're going to divide by g, so you get t squared equals 2d over g. Okay. And then I'm going to put this d squared plus d squared, so you get v naught squared t squared equals 2d squared, and you divide by t squared by both sides, so then you get v naught squared equals 2d squared over, you know what your t squared is, which is 2d over g, so you plug that in, 2d over g, and then you could flip these, put 2d squared over 1 and flip these to multiply over 1 times g over 2d. So then one of the d's cancels out and the 2's cancel out, so then you get v naught squared equals dg, and to get rid of this square you have to square root it, so then you're left with v naught equals square root of dg, and that is your answer for number 6. And then I'll erase. I'll pause it and just redraw this graph and explain that. Say when.
Go.
Alrighty. So I drew out the graph again just to have more room. So you look at your position to get your velocity, and you look at your velocity to get your acceleration, and then there's the force diagram. So for flight, it's like this, and for y, it's going to be like, like this. For landing, So then this is heading towards positive direction. So that's gonna look like this. This one is going, it's like going positive, then heading negative. So that's gonna look like this. And this one, like that. And this one's going towards a negative, so that's like that. And then this one, it's going to be here, it's constant. And this one,